Students, in this video we will study about isomerism. We will study about isomerism. First, what do you mean by isomerism? So, isomers are the compounds that have same molecular formula but different arrangement of atoms. Already we have studied in the first PUC. So, mainly these isomers are classified into two types. One is structural isomers and one more is stereoisomers. So, actually phenomenon we will call it as isomerism. So, structural isomerism again they are classified into four types, that is the ionization isomers, linkage isomers, solvate isomers, coordination isomers. And stereoisomers are classified into two types. First one is geometrical isomerism, second one is optical isomerism. See the first one now, ionization isomerism, it comes under structural isomerism. So ionization isomers, so see the example now. The example is a pentamine bromido cobalt 3 sulfate, and one more example you see, pentamine sulfate sulfate of cobalt 3 bromide. So what difference we can find out in both the cases? So both examples are there. First thing, almost both are having the same molecular formula. So here also cobalt is a metal, here also cobalt is a metal, and 5 ammonia ligand are there. Here also 5 amine ligand or ammonia is there, and one sulfate, here also one sulfate, one Br is there, here also one Br is there. So same molecular formula. What difference we are finding here? Only they differ in the counter ions. Only they differ in the counter ions. So if you dissolve in a water, so there sulfate ion you will get, and here bromide ion you will get. Sulfate will answer for sulfate test, that is a barium chloride test in organic analysis. Br will answer for AgNO3 test. See here we are finding only the difference in the counter ions. So what we can define? So isomers which are having same molecular formula but differ in the counter ions, either we can define isomers have same molecular formula, counter ions in the complex salt act as a potential ligands and displaces the ligands. Either we can define, either we can define isomers having the same molecular formula but ionize in solution giving different ions. So ionization isomers result from exchange of ions inside and outside the coordination sphere, means same molecular formula differ in the counter ions. Second one, linkage isomerism. So the name itself, linkage, differ in the linkage. So this linkage isomerism, it arises in the coordination compound which contains ambidentate ligands. You know ambidentate ligand means what? Ambidentate ligand means which are having two or more donor atoms, but any one donor atom can donate the pair of electron and which can make bond with the metal. So we can find out here differ in the mode of attachment of ligands. See the example, pentamine nitrito N cobalt 3 sulfate. Same way, you can see one more example, pentamine nitrito O cobalt 3 sulfate. Now if you see the structure of both the case, if you see the structure of both the case, see here cobalt is directly attached to nitrogen, here cobalt is attached to oxygen. Only the differ in the linkage, but molecular formula of both the coordination compounds is same, only differ in the linkage when it arises when there is a presence of ambidentate ligand. When there is a presence of ambidentate ligand, only they differ in the linkage. Now next one, hydrate or solvate isomerism. Hydrate or solvate isomerism. So what do you mean by hydrate or solvate isomerism? The name itself indicates hydrate. Hydrate means water. Okay, you know hydration, water. Solvate isomerism. Now see the example. So here examples they are given, hexa aqua chromium 3 chloride. Again they are given penta aqua chlorido chromium 3 chloride. So it is a violet color first one, and second one is a blue green color. And third one also given tetra-aqua chromium dichlorido chromium 3 chloride. That is a green. That is a green color. Now you see the difference in the cases. So they only differ in the water molecule. That is a solvent molecules, water molecule. So what we can define? Same molecular formula but contains different number of water molecules as a ligands. So that is nothing but what? Hydrate or solvent isomers. See, inside the sphere 6 water ligands are there, second one 5, and third one 4 are there. Now go for fourth one, coordination isomerism. Coordination isomerism. So see the first example, hexaamine cobalt and hexacyanidechromium, and see the one more example, hexaamine chromium and hexacyanide cobalt. So if you see the example, it is like twins. So twins means already you know. So two coordination compounds are there, means two spheres coordination compounds are there. So both together we will consider it as a one compound, coordination compound. Both together we will consider one coordination compound because one will act as a cation and one will act as a anion. One is a cationic part and one is anionic part. So when like twins or when like this coordination compounds are present, that time coordination isomerism arises. So which are having the same molecular formula but only differ in the, see there is a interchange in the what, ligands, either we can consider metals. So there will be interchange of ligands between cationic and anionic entities of different metals ions present in a complex. You can see the interchange of the ligands. Now the second type of classification, that is a geometrical isomerism. So geometrical isomerism arises in heteroleptic complexes, that is due to different possible arrangement of ligands. That is because of different possible arrangement of ligands. So if the coordination number is 4, we know that the two different geometries, that is one is square planar and one more is tetrahedral. So we can find out the geometrical isomerism in square planar complexes. In square planar complexes. Now you can see the square planar complexes with the coordination number 4. With the coordination number 4. So here metal X is one kind of ligand and L is one kind of ligand. So two ligands are there. Here coordination number is 4 and the hybridization is DsP2. Geometry is square planar. So both are monodentate or unidentate ligands X and L. So take a particular example. Diamine dichlorido platinum 2 it is. So the two ligands are arranged adjacent to other if two ligands, same kind of ligands, are arranged adjacent to other, then it is called cis isomer. You can see ammonia are with the same side, chlorido is at the same side, then it is called cis isomer. If it is opposite side, then we will call it as trans isomer. You can see now both are opposite, it is called trans isomer. So tetrahedral complexes whichever are there with the coordination number 4, they do not show geometrical isomerism. Remember students. So tetrahedral complexes do not show geometrical isomerism. Now with the coordination number 6 also there is a possibility of geometrical isomerism with the coordination number 6, that is octahedral complexes. Now we'll go through the octahedral complexes. So geometrical isomerism in octahedral complexes. See the example. So metal with coordination number 6. So all monodentate ligands are there. There are 6 monodentate ligands are there. So coordination number is 6 and the octahedral complex. So here X and L are monodentate ligands or unidentate ligands. M is a metal. So with respect to that, we'll take the particular example. That is nothing but tetraamine chlorido cobalt 3. So in this case, you can see chlorido, there are two Cl are there. Both Cl chloride are at the same side. Both the Cl at the same side here. So that's why it is called a cis isomer. That's why it is called cis isomer in octahedral complex. If it is in a different side, in any other position, we can see now Cl are both are opposite side now. It is called a trans isomer. It is also same like a square planar complex. Same side, opposite side. Cis isomer and trans isomer, these are called geometrical isomerisms. See one more example. Metal with the coordination number 6 octahedral complex. So two ligands are monodentate here and the two ligands are bidentate ligands. So X is a monodentate or unidentate and the LL I have represented, it is a bidentate or didentate. Take a particular example. Dichlorido bis-ethylene diamine cobalt 3 complexities. See in this case also both the Cl ligands are at the same side. Ethylene diamine at the one side. So Cl are at the same side, then it is called cis isomer. If it is the opposite side, then we can call it as trans isomer. These are geometrical isomers. Take one more example. Metal with the monodentate ligands 3 3. So 3 monodentate one kind and 3 monodentate ligands another kind are bonded to the metal. So if three donor atoms of same ligand occupy adjacent position at the corners of the octahedral face, we have facial isomer. You can see amine or ammonia. Amine is at same face, at one face. At one face, all three ligands are there, amine. Even if you see the nitro also, they are also at the one face. See the face now. This is one face and this is another face. So these are called facial isomers. If it is a different site, if it is a different site, now see ammonia are the opposite side here, nitro also they are not in the same phase, so then it is called meridional isomer, then it is called meridional isomers, and the phenomenon we will call it as meridional isomerism. Then optical isomers or optical isomerism, so they are mirror images that cannot be superimposed on one another. So non-superimposable mirror images. Non-superimposable mirror images are called optical isomers and the phenomenon is called optical isomerism. So the isomers which rotates the plane polarized light to the clockwise and anti-clockwise, right or left. So clockwise means dextrorotatory, anti-clockwise means leo-rotatory, small l and small d we will represent. Now we will take a particular example, tris ethane 1,2-diamine or tris ethylene diamine cobalt 3 it is. So it exhibits optical isomerism. How it exhibits? You can see the structure. Both are mirror images. Both are mirror images, but they are not superimposable, non-superimposable. If you keep one above one, just I'm giving the example to understand. If I keep one above one, you will get the same image of one each other. No, you will get different. Similar way, you take one example, you keep 1 rupee coin this side and 1 rupee coin this side. So 1 rupee coin mirror image. Now both 1 rupee coin you keep one above one. Now both are same. That is called superimposable. If it is different, then it is called non-superimposable. So non-superimposable mirror images means they are optically active. They rotate the plane polarized light are called optical isomers, and the phenomenon is called optical isomerism. You can see one more example. So here, so the complex is dichlorido bis-ethylene diamine platinum 2, sorry platinum 4 here, platinum 4. So this also shows optical isomers because non-superimposable mirror image. non-superimposable mirror images, they are optically active because they will rotate the plane polarized light clockwise and anti-clockwise. Clockwise dextrorotatory, anti-clockwise levorotatory. So trans is optically active because you will get symmetry there. That's why optically inactive. If you get the symmetry, you will get the optically inactive. If the symmetry is not there, then they are optically active.